Hi everybody. Today we're going to talk about inscribed angles. So we left off at talking about congruent chords and arcs and arc lengths. Okay, inscribed angles is not the next page, it's actually a little bit further down. There it is, there's the congruent chords. So skip ahead, it's actually a few pages down and look for the page that says inscribed angles. That's the one we're going to talk about in this video. Okay, so an inscribed angle is an angle whose vertex is on the circle. An angle whose vertex is on the circle. So if you look at this angle up here, the inscribed angle that you can see, there's a vertex to this angle right here, and it's on the circle. It's not in the center of the circle like our central angles were. So central means center. Inscribed means that vertex is right there on the circle. Okay, so there's a special relationship with those angles and how the angle is related to the arc that it makes. So this is arc AB. Okay, and that relationship is that the measure of the angle, so the measure of angle ACB, is equal to half of the measure of the arc that it inscribes. Okay, so when we had a central angle, those measures were exactly the same, but when the angle moves back here down to touch the side of the circle, now that angle is going to be half of this angle up here. So if we said this was x for this arc, then this angle is 1/2 x. Okay? You can also think of it as, if you drew it the other way, you could say if this one was A, then this is 2 times A. So there's two ways to think about it. Okay? If they give you x, then you divide it by 2 to get the angle. If they give you the angle, then they multiply it by 2 to get the arc. Okay? Alright. The other thing we're going to talk about is an angle formed by a tangent and a chord. Okay? So here we have a tangent on this side, and then we have a chord on this side, and they create an angle, and that angle is right here. Okay? And they call it, it says an angle formed by a tangent and a chord is an inscribed angle. So what does this mean? This means that it has the same relationship as an inscribed angle does. Measure of angle ACB is half of the measure of angle AB. So you would say the measure of angle ACB equals 1/2 the measure of arc AC. Okay? So we've got our inscribed angle, and here is the arc that they're referring to. Okay? And you could think of it the other way around too. You could think of it as here's an angle, and it's half of this not semicircle, but big part of the circumference here, this arc. Okay? Alright, so we just have a few examples to look at here. So the first one says, find the measure of arc AB. They want you to find the measure of AB if ACB is equal to 72. Okay? So if this is equal to 72, then the arc, remember we talked about, if they give you the angle, then the arc is going to be twice the angle. So we just say 72 times 2 equals 144 degrees. Okay? So the arc is just twice the angle. Okay? If it's inscribed. The second question says, solve for x if the measure of angle AB equals 5x minus 22, and the measure of angle ACB equals 2x minus 7. And I said angle, but I meant to say arc there. So let's just draw a picture of it. Here, I'm just going to draw it beside there. We're going to draw the same picture so we can have those labels up here. So we've got A, B, and C. And it says if arc AB is 5x minus 22, and angle ACB is 2x minus 7. So remember, how are they related? Well, they are related because if I take this angle and multiply it by 2, I get this arc. And I do actually prefer the multiplying method because dividing is a little bit harder. So if I take this angle and multiply it by 2, so that means I have to put it in parentheses, this angle times 2, I get the arc, which is 5x minus 22. Does that make sense? This angle times 2 equals the arc. And then you just distribute. Find Texas, which is over here. So subtract 4x from both sides. And then add 22 to both sides. So x equals 8. Okay? Alright, second example. This one's the one with the tangent and the chord. And the tangent and the chord are creating an inscribed angle. Remember, because this point right here where they intersect is a point on the circle. So, it says, the first one says, find the measure of arc AB. I think they mean arc AC. Yeah, arc AC. That should be a C right there, because B isn't even on the circle. So they want you to find the measure of arc AC if angle ACB is 72. So remember, the angle and the arc are related by, if the angle is 72, the arc is 2 times that, right? So we're going to say 72 times 2, that's 144. Okay? So the measure of the arc is 144. And now let's just talk about the measure of angle ACB. So this is angle ACB if arc ACD is 298. Or sorry, ADC is 298. Okay, so let's draw that picture so we can see what it looks like, as we've got writing on the other one. So AC, and then we have our tangent. Okay, and then we've got D. And it says AD, here's A, here's B, and here's D. Okay, so it says ADC, that arc, that whole arc is worth 298 degrees. So if this part of the circle is 298 degrees, we can find the other part by subtracting it from 360. So we'll say 360 minus 298, and that gets you 62. So if that's 298, then this side is 62, and that's for the arc. Now remember, if we're looking for the angle right here, then those are related because the arc and the angle, if I know the arc, I'm going to divide the angle by 2. Does that make sense? Or sorry, if I know the arc, I'm going to divide it by 2 to get the angle. So the arc is 62, so I'm going to divide that by 2. And that gives me the angle. So the measure of angle ACB is 31 degrees. Okay? So this one we had to subtract from 360 to get that leftover amount. And then remember the relationship, this is half of the actual arc. Okay? Don't forget, with central angles, the ones that are in the middle, that's when they're going to be exactly the same size. Alright, thanks for watching and have a good day.